Hello students, let us continue the session on revision in the chapter circles. The second question is two tangents PQ and PR are drawn from an external point to the circle with center O. Prove that QORP is a cyclic quadrilateral. For a cyclic quadrilateral, we know that it should have two properties. One of the properties is the opposite angles, they must be supplementary. And one more property is the external angle should be equal to its interior opposite angle. Either one of the property must holds true. Here PR and PQ, they are the tangents, and we know that a radius is perpendicular to the tangent. Since the radius is perpendicular to the tangent, we have angle PRO equal to 90 degrees, and this will be equal to angle PQO also. We all know that in quadrilateral, the sum of interior angles must be equal to 360 degrees. So in the quadrilateral QORP, we have angle P added to angle Q added to angle R added to angle O must be equal to 360 degrees. We have these two angles equal to 90 degree each, so we get angle P plus angle O equal to 180 degrees. Since these are the opposite angles, we have angle Q plus angle R also is 180 degree. These two, they are opposite angles. Since the opposite angles are supplementary, we can say that quadrilateral QORP is cyclic. Question 3. If from an external point B of a circle with center O, two tangents BC and BD are drawn such that angle DBC is 120 degree, prove that BC plus BD equal to BO, that is BO equal to 2 times of BC. Let me plot the figure here. The angle between the tangents is 120 degree, so each part, angle CBO and angle DBO, they are 60 each. For that, I would like to write the reason. I will just mention triangle OBC is congruent to the triangle OBD. The reason is by SSS criteria, or you can write SAS also. In this case, I am taking the three sides. These are the equal sides of both the triangles. So by SSS congruence criteria, the triangles are congruent. This implies angle OBC will be equal to angle OBD, and both the angles will be equal to half of the angle DBC. So we get it as 60 degrees. This part is done. Now you look at the radius. Radius is making a right angle, so in a right angle triangle I can make use of Pythagoras theorem. If I consider cos of 60 degree, we get the adjacent side BC upon the hypotenuse BO, that is in the triangle OCB. In this triangle, cos 60 degree is 1 by 2 1 by 2 equal to BC divided by BO. Hence we get OB as twice BC. So this is done. And we have proved the congruency. Since BD and BC they are equal, we can write OB as BC plus BC. Now instead of BC I can consider BD. So OB is equal to BC plus BD. So both the things are done. Question number 4. Prove that the center of a circle touching two intersecting lines on the angle bisector of these lines. Let me draw a figure with respect to the question. In this, two intersecting lines are AT and BT. They are intersected at T. And the center of the circle is O. And these two lines, they meet the circle at A and B respectively. What is to be proved here? We need to prove that OT bisects angle ATB. Let us do a construction. Let me join OA and OB. They become the radii. And let's prove. Since radius is perpendicular to tangent, we have angle OAT equal to 90 degree and angle OBT is also 90 degree. Now in the triangle OTA and OTB, we have angle OAT equal to angle OBT, both equal to 90 degrees. There is a common side OT, so OT is equal to OT, it is common side. And we have OA equal to OB, they are the radii. Therefore the triangle OTA is congruent to triangle OTB by RHS criteria. Therefore angle OTA equal to angle OTB. This implies that OT bisects angle ATB, hence proved. Question number 5. In the figure 9.13, AB and CD are common tangents to two circles of unequal radii. Prove that the length of AB and CD are equal. To prove, let me make construction. Let me produce this AB and CD and let them meet each other at a point P. So that's the construction. The construction is produce AB and CD up to point P where both tangents meet. Since we know that tangents from an external point to the circle are equal, the length of PB will be equal to the length of PD. Let me name this as 1. And the length of PA will be equal to the length of PC. Let me name this as 2. The reason for both, I'll mention it here. The length of tangents from external point are equal. Let's do equation 2 minus equation 1. we get PA minus PB equal to PC minus PD. What is PA minus PB? It is AB. What is PC minus PD? It is CD. So AB will be equal to CD, hence proved. Question number 6. In question 5 above, if radii of the two circles are equal, prove that AB equal to CD. Look at these two figures. If the radii are equal, the circle looks like this. I have marked circle with centers as O1 and O2. AB and CD, they are the tangents. Let's do the construction. This is the construction. I have joined O1A, O1C. Let me write that. Construction. Join O1A, O1C, O2B, O2D and O1, O2. Let's prove. Since the tangent at any point to the circle is perpendicular to the radius, since the radius is perpendicular to the tangent, we have angle O1AB equal to angle O2BA. This is equal to 90 degrees. If you observe carefully, it forms a rectangle because O1A is equal to O2B. This is equal to this implies O1AB O2 is a rectangle. Since the opposite sides of the rectangle are equal, I can say that AB will be equal to O1 O2. Similarly, we can consider the other pair. We will be getting the length of CD equal to O1 O2. Let me name this as equation 1. Let this be equation 2. From 1 and 2, we get AB equal to CD. Very simple. Question number 7. In the figure 9.14, common tangents AB and CD to two circles intersect each other at point E. Prove that the length AB equal to the length CD. These are the two non-intersecting circles and the tangents are AB and CD. They are intersected at point E. We know that the length of tangents from a point exterior are equal. Length of tangents from external point are equal. This implies the length of EA will be equal to the length of EC. Similarly, the length of EB will be equal to the length of ED. Let me name this as equation 1. Let this be equation 2. Let's add this equation 1 with equation 2. What do we get? EA plus EB equal to the length of EC plus ED. EA plus EB is nothing but AB, which is equal to EC plus ED, which is nothing but CD. Hence proved. Question number 8. A chord PQ of a circle is parallel to the tangent drawn at a point R of the circle. Prove that R bisects the arc PRQ. Let's take a figure. In this figure, PQ is a chord of the circle. I have taken MN as the tangent and R is the point where the tangent meets a circle. We need to prove that R bisects the arc PRQ. That means we need to prove that the arc length PR is equal to the arc length RQ. This is what is required to be proved. Look at the chord PR. The chord PR subtends angle 1 with the tangent MN. So I can say that angle 1 is equal to angle 2 from theorem. Since we have MRN, let me erase that part. Angle 1 and angle 2, they are alternate. And they are alternate angles. So we have MN parallel to PQ. Since MN is parallel to PQ, angle 1 will be equal to angle 3. This implies that angle 2 will become equal to angle 3. Since angle 2 and angle 3 are equal, we can say PR will become equal to RQ, because the sides opposite to equal angles. If the chords are equal, the respective arcs will be equal. So the arc PQ will become equal to the arc QR. This proves that R bisects the arc PRQ. Therefore, R bisects arc PRQ, hence proved. Question 9. Prove that the tangents drawn at the ends of a chord of a circle make equal angles with the chord. Look at this figure. We need to prove that angle 2 and angle 1 will become equal. Here, we need to prove that angle PAB equal to angle PBA. We know that the tangents drawn from external point to the circle are equal. So we have the result PA equal to PB, because the length of tangents from external point are equal. Since the length of arcs are equal, in triangle PAB, we have angle PAB will become equal to the angle PBA, because angles opposite to equal sides are equal, hence proved. With this question, I'll end today's session. We shall take up few more questions in the next session. Thank you.